Hello, my name is Ksenia Gasic. I'm a peach breeder at Clemson University, and today I will share with you my perspective on using the breeding information management system in my peach breeding program. Before I do that, I will talk to you about my program, about the data type that we collect, how we collect the data and how we manage it, and demonstrate the breeding information management system, or BIMS. Clemson University Peach Breeding Program was established in 2008 from scratch because there was a gap between my program and the previous breeder about 25 years. South Carolina is second in the nation in fresh market peach production. Therefore, the goal of the program is to develop high quality disease resistant peach varieties that are adapted to our environmental conditions in Southeast. To do that, we have to address several challenges, including climate change, consumer demands, producer needs, and retailer education. Now I'm going to tell you about the data type we collect in the breeding program. And like every breeding program, we of course collect phenotypic data in field and in lab, and molecular data, which could be markers, SSRs at the beginning and now mostly SNPs, genotypes, haplotypes, and all of these data are housed at the genome database for rosace. How we collect the data is basically using the field book that you heard all about it in a previous presentation, so I'm not going to go into details here. And we upload the data into the breeding information management system, which is the topic of this talk. So what is BIMS? BIMS is a secure and comprehensive online breeding data management system that is housed in the community databases, allows individual breeders to store, manage, archive, and analyze their private breeding data, allows you access to public breeding data, and is freely available at these 5 databases. So if your crop does not belong to any of the databases that house BIMS, you can still use it for free. You just need to go to this website, click BIMS, request the account, and start using it. So data management in BIMS, when your crop belongs to one of the databases, looks like this. You go to the database where your crop belongs to, and mine, peach, belongs to genome database for rosace. There are you log in, that's why it says my account, because I'm already logged in here. Under the tools, BIMS is the first option. You select it and it takes you to the page of all the crops. I went backwards because since I'm logged in, it will go immediately to my program, but just to show you what are the options and all of the crops that this database houses, you can choose different ones, and then you can see how many public, private programs, etc. There are. So going into my breeding program in BIMS, you can see that I have 3 private breeding programs and I can have access to 2 public breeding programs. In this page, there are several sections that I want to point to. The top section, or the top panel, shows you the crop, program, and information who's logged in. The side panel or sidebar shows accordion menu, in which by clicking you can open options and you interact with the database. And the main panel basically shows you different options and views depending on what you chose in the sidebar. Once you request the account and you log in and go into the BIMS, first thing is for you to create a program. So you would go into the admin menu for program, and when you click that, it will show you 2 options: to create the programs and to add the members. So first we'll create the program. When you click that, this is the panel that opens, and there are several sections where you need to fill information. For example, the name of the program and the information about the accession, unique identifier, primary order, and secondary order. Those informations are required by Fieldbook, and they are fully customizable, so you can choose anything you want. In my case, I kept the default accession and unique ID, but for the primary order, since I'm working with the trees, I use row and tree for a secondary order. Once you fill these sections, then you click create and you created your program. The next step is of course to add the members, and so in this panel you can add and manage the members' rights, and you can see in these red boxes selected that you can give permission to access the data, upload only with templates, upload only with fieldbook data, or read only. You can also remove the members. One note, members have to be added to the database, so they have to request the account so you will be able to find them in that non-member section in this page. So after you create the program and add the members, you want to add the data. There are several ways how you can add the data in the BIMS, and one is the first and most simple one is the manual adding the data. When you go in each of these sections in the accordion menu, it will open the window and the option to edit or adding the new data. This is the slowest way, and sometimes you use it if you have just few data points you want to add, like few accessions, crosses, and stuff like that. Most of the times you will use templates, and when you click data import, which is in the left side accordion, you can see data import there, and when you click it, it's gonna populate the options, and there are templates that you can use to upload your data. This way is used for uploading historical data, or let's say data collected in the lab in my program's case. And of course, you can upload the data with a fieldbook, and there are several ways you can upload it directly using BRAPI, which is a really cool thing. With just click of a button, your data are back into the database, or you can download the file and manually upload it, or in the worst case scenarios, those two doesn't work, you can basically download the data and put it into the template and upload it. So I've done all three ways for various reasons. Here you can see the template list or various data that you can upload. If you click on the bottom red box where it says click here, you can download a single Excel file with each of these template as a separate sheet within the file. And that's what you would usually do when you're starting your program and when you set up information and put your descriptor in, contacts, accessions, crosses, and etc. But after that, you would usually just use one or two, basically accession, phenotype if you're uploading phenotype data, or genotype if you're uploading genotype data. So here is just a short reminder of how it works with the fieldbook, because you already heard it in previous presentation. So basically you collect the data, and then the screen pops up for the BRAPI export, which allows you to upload directly to the BIMS all the new observations, image data, notes, etc. One of the things that I want to showcase to you is a cool feature that Fieldbook has about using geolocation to locate your trees. Why is that important in my program is because when I do the selection after the first level to move the selections to the next level, I remove the accessions I don't need, and then many times labels are lost and it's really hard to locate what tree exactly it is. So geonavigation works wonders. So as you can read on this slide, Fieldbook has a geonavigation component. You can activate it. You first need to use these type of gadgets to map your trees in the field. You can map them by having the base and the rover and using the base to map the field, or you can log in into the state's geonavigation network. And for example, in South Carolina, it's not free. You have to pay $600 annual fee to be member of that network. But let's say North Carolina or Oregon, you can freely access that network. And then once you map your orchard, you can navigate, which is that right-hand picture circled in the red. Now set it up so it automatically navigates to the tree that it's next to you where you're standing. And to make a more visual how it looks like, this is a member of my lab that has the phone and or tablet with the Fieldbook app, has a rover in the backpack, walks the field, gets to the tree, and then Fieldbook automatically goes to the mapped tree. In a nutshell, this is how it works in my program. We collect the data in the lab or in the field with the Fieldbook. We automatically transferred Fieldbook stuff through the BRAPI. We use the manual data transfer or manual templates for uploading the lab data into BIMS, and then we use BIMS for data management, search, and any routine applications in the field. So what is the biggest improvement in my program with using the Fieldbook and the BIMS is ability to sync the data on individual gadgets that are using the Fieldbook to collect the data. If you're like me, in your breeding program, you can have several people collecting data for you. Unfortunately, there is no way to just put sync two individual gadgets for the Fieldbook app. So BIMS does that for you. You export the data to the BIMS from all of the gadgets. It goes to the same data trials, and then basically you just sync it back to the individual app on individual gadget, and that way everybody knows what's evaluated and what's already stored in the database. Now I will demonstrate BIMS in a few features how we use it in my program. So the first feature basically that I mostly use is a phenotype search. On the left hand side where you see the red box, it will list the type of data that you have. Right now in my program, I have only phenotypic data because genotypic data are stored within the GDR database, and we are now looking for a way to link my accession data to the data that's already in general for the whole crop in the database so we do not duplicate. So here I'm searching for the phenotype, and I would first click on trial and select the trials I want to look into. So P30 is the trial for advanced selections in my program, and then I selected from 2018 to 2022 all of these years data because I want to look fruit weight that was recorded in those years. One of the things to point out for the setting up the trial, if you work with a perennial crop like I do, I go back annually to the same field to collect the data from same accessions. To be able to see those individual data, we have to set up the trials for each of the year for one specific orchard, and that way, that's why I have P30 from 2018 to P30 from 2022, and now 23 and 24. Once you set up what you want to look for in the property box, there are traits, and here for this example I chose fruit weight. Then the bottom panel appears where you can see all of the data in these trials and minimum and maximum of the fruit weight recorded. If you look at the right hand side box that appears, you can see that when I just selected the trial, I actually selected over 2,000 samples with over 43,000 phenotypic means collected in those 5 years. When I selected fruit weight, it cut the number of the samples because not all of the samples have fruit weight recorded. And just to remind you that within the trial, we upload the data from field, from lab. So I don't record the fruit weight in the field. That's why the number of the samples is lower. And it says 30,000 phenotypic means. And then you can view the data, you can analyze it, or you can choose another trait that you want to either even funnel more within this data set, or you can go backwards and start from the beginning. You can also view individual accessions data. And how to do that is basically in the left accordion panel, you click on the accession. this window will pop up. In the find box, you will type the name of the accession you're looking for. If your program has less than 2,000 accessions, then you will see the drop-down list and you can select it. As you can see, my program has almost 7,000 accessions listed, and that's why I have to type. Once you start typing, it basically opens up the window showing you everything that starts with those few first characters that you type, which helps choosing the correct selection. In this case, I selected SC1 selection, which is the first one that we patented in my program. And you can see here, that's why I'm not worried that you see the parental information and everything else. And you can see one more thing that I want to point here under the alias. You can see that there are two additional names. So my material gets the original name, which is SC10-21001, which means that the cross was made in 2010, it was cross 21, and it was first 3 in the cross. Then when it goes to the replicated trial, we rename it. And this was the first one that we included into replicated trials with growers, and it got SC1. And now this was the first one that's released, and we named it, basically it was patented as Everest Ruby. So that's why the name changed. So the next thing in this page that you can do, you can view samples. You can see that there is a 34 samples that SC1 was evaluated. When you click this button, you will see this page. It still keeps the accession properties, but it gives you also the data collected depending on the trial that you selected. In this case, shows you the compiled data, and under that, under the sample, you see that the trial is compiled data P30 2020. What that means is all of the lab data in my program are uploaded, as I said, with the templates, and they are named as a compiled data. And so this is the data from 2020 of phenotypic data from the lab, and for that particular accession, and you can see the data on the right hand side. Going back to the manage accessions, you can use and see the statistics for the particular data that you collected for this accession, and when you click that, there is a list of traits. You can select the trait, in this case fruit weight, and you can see the fruit weight on all of the samples collected and some statistics. And then you can see here phenotyping data, all of the individual data that were collected. And when you open that up, scroll down, and on the right hand side you can see all of the files that were uploaded and all of the data collected. On this page, you can actually manage some of the data. You can delete all data for this accession. You can edit it, and you can see if there is a photo that is uploaded just about this accession, but I'll show you the photo upload directly from Fieldbook because of the time. And you can see any other documents, and under these documents, what I've uploaded was the patent information for this selection in my program. Viewing image is very simple. Again, you're at the accession, and when you see the view photos, if you click on this, then you can scroll with the buttons in the bottom of this picture and see all of the pictures that are collected with the Fieldbook, exported with BRAPI, so the same day I collect them, I can look at them on the page in my desktop computer, which is really cool. Of course, genotype search works the similar way, where you select the SNP or this type of genotype. For this example, there is a SNP genotype. You can choose markers based on the property, based on their name, or you choose genome location. And then here you choose the genome type, because this is the example from cotton. There are several different genomes that are available, so you can put a drop-down menu and choose it. You choose the chromosome, you choose the location, and then it tells you how many markers are matched with genotypic SNP measurements, and then you can download, view the data and download it. In a nutshell, I'm at the end of my talk. BIMS is a solution to integrate breeding data from various sources. One of the coolest thing is free. It's an online database. It's connected to crop databases. It has a customized features and strong technical support. If you attended the fruit and nut workshop yesterday, you heard in details about other features, but one of the biggest one is that's archived daily, and each of the users can archive it anytime they want it and download the version of the database on their local computer anytime they want. If you want to learn more about BIMS, these are the places where you can go. There are manuals, video tutorials, and you can check it either in the 5 databases or at Breeding with BIMS. So we want to thank the federal industry and funding and community support, and I want to thank to you for your attention. Any questions you have about this talk, you can shoot me an email, or in general about the BIMS, Dr. Jang is present so she can answer that. Thank you. Enjoy the conference.